Okay, let's get started. So this is gonna be still gonna be 25, but this is probably gonna be more integration technique. It's about like a trig substitution. So it is math 125. It's calculus 2. So gonna be section 7.3, the trig substitution integral part 1. The column integration by trig sub. Part 1. So the main purpose of the trig sub is to convert a polynomial expression under the radical into the form we can use the trig integrals. So main goal of the trig sub is to convert polynomial expressions into trig expression. Into trig product functions. And then use 7.2 techniques. Then integrating, use 7.2 techniques. So it's basically very same as 7.2, which you had different cases. If you have anything like the Naomi, the case 1 is where is like a squared minus x squared. But first of all, let's introduce some of like the harder integration kind of integrals. So let's we'll use like the frame there, like 3 integrals. That you may need to use for integrating future functions. So the integral of tangent of x dx, it is going to be natural log of secant of x plus constant of integration. And number 2 is secant of x dx is going to be natural log of absolute value secant plus tangent. Plus constant of integration. And last one is just secant to the cubic. This is going to be like the hardest but you don't need to know how to integrate the secant per cubic. It is here. It's going to be 1/2 of secant of x, tangent of x, plus 1/2 of natural log of secant plus tangent squared. Just abbreviate Pascal of integration. Well, those maybe appear on the future integrals, but I can't just I'm not gonna just prove how this come, but that's not the trick sum. So case 1 will be introduced is gonna be a squared minus x squared. So case 1 is a squared minus x squared. In this cases, the way we would do is like a equals to, this way we're gonna introduce is gonna be x equal to a sine of theta, and then we produce a new integral. And let's try an example. Evaluate this integral. It'll be well, in this case, you might just think, well, I'm gonna do a u sub, or this is arc sine. No. Calm down. This is let's do some tricks up, because this is not u sub. Okay. A equals to 1, so this basically treats the 1 squared minus x squared. So like the u, which is going to be x equal to 1 sine of theta, the dx, it is 1 cosine of theta, the theta, and then we just rewrite the whole integrals here. So new integral, and it's gonna be sine cubic of theta. Now this is gonna be 1 minus sine squared. And then times cosine theta, the theta. This is going to be cosine squared, and the square root of cosine squared is the cosine of x. It's going to be sine theta squared. Oh no. And then going to be cosine of theta, and then cosine of a theta d theta. And then is the gonna be sine the cubic of theta d theta. The sine has an odd. Then we just need to refactor we use the cosine squared. Equal, and it's gonna be sine squared of theta, sine of theta d theta, And then we rewrite the trig as 1 minus cosine squared of data sine of data d data. The u equals to cosine of x. du it is sine data d data. du is going to be negative sine data d data. We just swap the negative sign. We just going to be swapped as the sign of u going to be u squared minus 1. U, and then it's just going to be and just going to be 1 over 3 over u3 plus u plus constant of integration, but not yet. If we have so if we have this 1 over cubic u squared plus u plus c, we need to replace this integral with cosine of x. Plus cosine of it theta plus c, but not yet. Here's the trick. The trick is like you needed to draw like a triangle, draw a graph here. So sine of theta it is x over a. So it is a 1, so it's just x over 1. So this side is going to be 1 minus x squared on the radical, and now cosine of x it is going to be cosine theta. It is going to just going to be this side over this, so it's just going to be 1 minus x squared, because this over 1 is also this. So we just write as going to be cubic 1 minus x squared plus this plus constant of integration. That is what you got from the integral. Okay, let's do another example. So this one is not going to be the same as the first one. Example 2, you're gonna do it's an integral. I'm making this mistake. I'll intentionally just do this. 4, not 9. So apologize for it. Okay. It's still the trick sub. So it's like, so if you use U sub, that's not gonna work. And then just gonna a equals to 2, because 2 squared is 4, so we let x equal to 2 sine of theta, then dx it is 2 cosine of theta, the theta. The whole integral it is going to be let's say but after the use of it, I need to change the bound because just the new integral is the theta's integral. So upper bound 2 equals 2 sine of theta. So theta it is pi over 2. And lower bound is a 0 equal to 2 sine of theta. So theta is a 0. So for any definite integrals, just must change the lower bound and upper bound. Well, I have a red pen. This is a definite integral. I'm just gonna say change. So gonna be change the bound. This is a definite integral. This will produce a new integral. Use the 7.2 strategy. X squared going to be 4 sine theta squared of x. Oh, theta, not x. And then it's going to be 4 minus 4 sine squared of theta and 2 cosine theta d theta. And then we get this integral pi over 2 gonna be 4 sine squared of theta over 4 cosine squared of theta, 2 cosine of theta d theta. And then just this is going to be 2 cosine of x. So now is another trick, pi over 2 and a 0. So it's going to be 4 sine squared of theta d theta. Now just going to be 4 is a constant. We need to hack this integral. So let's hack it. This is using the double angles like the sine squared. That's going to be 1/2 over 1 minus cosine of 2 theta d theta. And then just still force the constant pi over 2 and 0 is going to be 1/2 minus 1 over cosine of 2 theta d theta. Then just evaluate this integral. It's just going to be, it's going to be sine pi and 2 is so it's going to be 4 2 theta pi over 2 and 0. This is going to be 4, going to be 1 cosine of theta gonna be pi and 0, so it's gonna be pi. So pi is the answer of this integral. So want to do like another one? Well, now it's like enough for like the trig. And let's do like a third one. Evaluate this integral. So perhaps we have well, this is like a product, but it might be intimidating for you just use the integration by part, but the trig integral is kind of a best way to solve this. So immediately you will just recognize x equal to 4 sine of theta, then dx it is 4 cosine of theta d theta. So this will give you it's like the integral of 16 sine squared of theta, and then just like the radical of 16 minus 16 sine squared of theta times cosine of theta d theta is 4. I forgot this 4 here. So we just pull the constant out of here. Maybe sine squared of theta. So it's gonna be 16 sine squared 16 cosine squared of theta, then there's cosine of theta d theta, and then you just it's going to be 4 cosine square, so 4 cosine of so this is going to be kind of interesting. Sine squared cosine squared. Well, this is gonna be like an interesting integral right now. So this is gonna be interesting. Okay, let's just do this integral. Have power of 2. And if you just you have this tricks and you just don't know how to do it, and you 7.3, and then just use the half onboard data, you just solve this integral because because this is like a special integral, so I will give you like a minute hang up to just think how to integrate this. use some like special identity to. Oh wow, this is the example thing, and you can just rewrite it. Cosine x squared. It's like I know what it do. So this just gonna rewrite as 256, and it's gonna be sine of theta cosine of theta squared, then the theta. Wow, I didn't know this hint. It's gonna be 1/2 sine of 2 theta squared theta, and then it's gonna be 256. The integral of 1/4 over sine squared up to theta d theta, and then just this is a sine even power. Rewrite again, Trig integral again, so it's gonna be shit. 64. Oh, how I just make the mistakes. And so it's gonna be 1/4. It's gonna be sine over square, so gonna be 1/2 over 1 minus cosine of gonna be 4 theta d theta, and then integration. Theta, and then it's just gonna be 32 theta minus 8 sine of 4 theta, and then plus constant of integration. Then draw a graph. You can't just leave it here, right? So here's the triangle. Perhaps it's like sine of theta is x over 4. So x to the 4, and then this is gonna be 16 minus x squared. Arc sine is gonna be so theta gonna be arc sine x over 4 sine of 4 theta, so just the x, so gonna be 8, so it's gonna be 8 times 4x over 4 plus constant of integration, and this is just gonna be 32 arc sine of x over 4 plus 8x plus constant of integration. Oh wow, that is a long integral. Okay, let's there's like a method, there's like they're going to be like another different type of integral that you encounter for trig sub. So let's do let's gonna do case 2. So for case 2, you will just like is a squared plus x squared. The u sub is gonna be a equal to x to the tangent of theta, because recall that tangent squared of x plus 1, it is secant squared of x. So example 4, that's my example. Evaluate the integral. So this case is, let's try like kind of an easier one because I know you guys kind of hate trig sub, right? Well, in this case, you're gonna do u sub. No, not u sub. Don't ever attempt to do u sub before doing trig sub. So in this case, you're gonna do x equal to 3 tangent x equal to 3 tangent of theta. Dx, it is 3 secant squared of theta d theta, and then we rewrite this integral, and it's going to be 9 plus 9 tangent of squared of theta times 3 secant squared of theta d theta. That will be 9 secant squared of x. It would be 9 secant squared of theta, not x. How does this thing's x? Well, I'm doing this. And now we get this. Well, if you see this, don't panic. We have this integration table for you, already mentioned earlier in this video. So it's going to be nine over 2 secant of theta tangent of theta plus 9 over 2 the natural log secant of theta plus tangent of theta plus constant of integration. So what is the secant of a theta, the tangent of a theta? Just to draw like, so we just sketch. We sketch with a triangle here. So tangent of theta is going to be x over 3. X of 3 is going to be 9 plus x squared. So the secant of theta is going to be 9 times going to be 9 plus x squared or over 3 then x over 3 plus 9 over 2, the natural log of secant is going to be plus x squared 3 plus tangent of x is x over 3 plus constant of integration. So just 9 canceled out. So it's just going to be 2x 9 plus x squared plus 9 over 2 natural log of x plus 9 plus x squared over 3 plus constant of integration. This is case 2. What do we what do we encounter for the c for a squared plus x squared? And I think that's all for part 1. And next video, in part 2, we're dealing with the third cases and completing square. Thank you guys for watching and have a great day.